Okay, good morning or good afternoon, everyone. It looks like it is, at least on my clock, it's 11 o'clock and time for us to get going. I'm Betsy Hill, president of BrainWear Learning Company. I want to welcome everybody to today's webinar, 4 practical ways to bring neuroscience to the classroom. A couple of, not able to open 2 of the files. Okay, they're all PDFs. So I don't know why that should be. Make sure you download them, I guess, first, Sonia, and hopefully that will work. If you still have trouble, you'll have my email address afterwards, and we can always resend any of those at a later time. So most of you seem to have effectively found the chat window, which is great. That is, please ask questions there along the way. Just type your question in. We will try to answer some questions along the way if we can, particularly those that where there's some confusion or lack of understanding of what we're talking about. But if we don't, we'll try to address as many of them as we can at the end. We are recording the session today, so you will automatically, everybody who's listening right now, will automatically, in fact, everybody who registered will automatically get a link to the recording when it is available. It usually doesn't take more than about 24 hours for that to appear, so to process and be posted. So if you have colleagues or others who couldn't attend today and want to share this with them, or you want to watch it again, that will be available to you. Most of you seem to have also found the download slides, which is great. And the other thing is that those of you who signed up and requested a certificate of participation for today's webinar, we usually process those within about a week. Sometimes we get so many requests, it takes us a few days longer than that, but generally you should be able to count on it getting that sometime either by the end of this week or certainly by the end of next week. All right, I think that's all of our housekeeping. When we think about neuroscience and the classroom, we might reflect on the fact that neuroscience is really already there. Here, classrooms are full of brains, the student's brains, the teacher's brain, and each of those has developed uniquely. Each of those brains is attending to something, whether it's what the teacher wants them to be focused on or something else is another question. Each brain is seeing patterns and deriving meaning or failing to see the patterns and the meaning. Each is connecting or not connecting with learning. So much we now understand about how brains develop, take in, code, store, retrieve, and manage information. But the research is often esoteric, and it's not always easy to figure out how to incorporate it. So we're going to try and give you a few thoughts about how to do that today. There are some practical ways that we want to share and that don't necessarily require teachers to become neuroscientists, which is good news, but that can result in dramatic changes in student learning. The first is cognitive training. We don't mean brain games here. We do mean serious brain exercises supported by research. The second is cognitive assessment. I don't know about all of you, but I would have given just about anything to get some insight into the learning strengths and weaknesses of my students and what that meant. It's been years in the making, but it's finally available. The third is a reading program that explicitly works on the cognitive skills most critical for reading and that are particularly important for reading comprehension. And last but not least is learning about the brain itself and what that implies for classroom practice and instructional strategy. So for each of these, we're going to address the why and the how. One thing I do want to mention is that if you are a school or a clinician and would like to explore a trial account for any of the programs we'll be talking about today, we would be happy to provide that, and we'll provide information at the end on how to make that request. So why cognitive training? Well, there are a lot of reasons, but I'm going to share a couple that I think are particularly important today. Here's one reason. The Organization for Economic Cooperation and Development, OECD, which is many of the developed nations in the world working together to try to help solve problems, did some research a few years ago looking at the connection between academic achievement, as measured by the PISA scores, and economics. PISA is that international test that students take around the world for comparison purposes. And what they concluded based on their analysis is that this is showing is the potential impact on U.S. gross domestic product, GDP, of raising the PISA scores by various amounts. Just raising the PISA scores in the U.S. to the minimum level of proficiency would uncover $72 trillion. Currently, the entire GDP of the whole world is about 75 trillion. So you can really appreciate the kind of impact. And most importantly, the report characterizes the gap, the reason that we're not performing at that level, as directly related to cognitive development. Another reason for cognitive training is the persistently lower performance of three groups of students. Students from low socioeconomic status, students with disabilities, and English language learners. All three of these groups lag the national average and have done so consistently for decades. Here I used parent education level as a proxy for SES, but if you looked at other data and students, for example, who qualify for free and reduced lunch, the data would look pretty much the same. And it would look essentially the same no matter what state we look at or what year. This has been something that has been very, very consistent for as long as we've been measuring education. And those were math scores. Same thing happens in reading. Almost everything that we've done in education to try to improve student performance and close this gap has focused on what I call external factors: the teacher, the curriculum, technology, the environment. What hasn't received enough attention, in my opinion, is what's happening in students' brains and the cognitive capacity they bring to the classroom. There's now an impressive body of evidence that looks at the impact of economic status on cognitive development. And on average, this doesn't mean there aren't exceptions, but on average, students from low SES have less well-developed cognitive abilities than their peers. They're more advantaged peers, but that doesn't mean they can't develop them. Of course, that's what cognitive training is all about. Students with learning disabilities, by definition, have less well-developed cognitive skills than their peers. And learning a second language while trying to learn current content knowledge at the same time is really daunting from a cognitive point of view. So cognitive development can play into helping all of these different populations. So the cognitive training tool we're going to be talking about today is called BrainWear Safari. It's a software program that develops cognitive skills in a comprehensive and integrated way. It is grounded in neuroscience, and it also comes from work that has been done in a clinical setting for decades. So there was a group of clinicians. It started with a vision developmental specialist and a speech and language pathologist who decided that they each had a perspective but not a complete solution for some of their clients. And so they started working together, and over the period of about 40 years, the group grew to 300 clinicians who shared best practices, what worked, and developed and refined a set of exercises that were very effective. There were, of course, still things that were delivered in a clinical setting. So they were paper and pencil and similar kinds of things and administered one-on-one. So what we did is we married this with video game technology so that it can be used much more broadly at a much, much lower cost. I'm going to share one little bit of research with you today, but there are a variety, there are over 30 studies that have been done with different populations in different parts of the country, in fact, different parts of the world. And they're all posted on our website if you want to go and take a look at those. The program is recommended for ages 6 and up, basically through adult, and the program does require a PC or a Mac to be able to use it. So when we talk about cognitive skills, this is a chart that we use to sort of explain what we mean. And I'm not going to go into a lot of depth today about how we use these cognitive skills in reading and in math and in everything else we do. A number of other webinars we do that, but essentially all of these skills are the foundation for learning. Down at the bottom, we have foundational cognitive skills, things like attention, visual processing, processing speed, sequential processing. These are the basic ways that information gets into our brains from the outside world. And so that's what starts the learning process. The next tier up, those are cognitive skills that are referred to now as executive functions. These are the directive capacities of our minds. So working memory, our ability to hold information in our mind while we think about it. Inhibitory control, pretty self-explanatory, when you are able to stop yourself from doing something that you would otherwise do. And cognitive flexibility, your ability to shift your mindset when the rules of the world around you change. And then on top of that are higher order executive functions. And what we're showing is that these sit underneath reading and math and everything else that sits on top of them, in fact, life success. And, while we asked to get asked as teachers to teach reading and teach math and teach technology and teach social studies and science, the fact is that we don't always have students with enough of this cognitive infrastructure to be as successful as we'd like them to be. So just quickly, here is an example of the development of cognitive skills for one of the populations we were talking about. Those are students with specific learning disabilities. And the pre and post test here was the Woodcock-Johnson cognitive battery. 94% proficiency is the level that's expected of a normally developing student. And you can see across all of the subtest areas of the Woodcock-Johnson what the control group, which were just students in schools with SLD, with a SLD diagnosis, who were also receiving their standard reading and math interventions. The BrainWear group on top of that used BrainWear Safari. And they used it for the standard protocol, which is 3 to 5 times a week, 30 to 45 minutes over about 12 weeks. So that's something also to keep in mind. So as you can see, the right kind of training can have a big impact on these cognitive skills. You can see how low these kids were in working memory, short-term memory, attention, and that we're getting them across the board very close to, sometimes even surpassing the level that would be considered normally developing. And of course, that we want to take a look at the impact on academics. Overall, these students cognitively increased to an average 89% proficiency, so virtually closing the gap to 90%, which would be considered normally developing. And that opens the door for much more rapid improvements in academic performance. Within 12 weeks, the average growth in reading was 0.8 of a grade equivalent, and in math, it was a full grade equivalent. So now we're going to take a quick look at BrainWear, and I have to juggle all these things, and I have to get over to my screen sharing. I'm going to share my screen, and I'm going to go to BrainWear. And we're just going to do a couple of little examples here to give you a flavor for it. Remember that if you would like to have a trial account to explore it some more, if you would like to schedule a fuller demo so that you can see more of it and more of the research, we're always happy to do that. So this is an exercise, one of the 20 exercises in BrainWear. It's called web weaving. And I'm just going to show you, this is actually level 2 rather than level 1. And you won't hear my sound because we're connected through the big marker platform, but I'll explain if there's any sound that's relevant, as there will be in this one. Okay, so when I click Start Challenge, I'm going to get a design on the left, and then it's going to disappear. And now I can hear a clicking sound. I can hear a metronome beat. And what I have to do is I have to click on the beat 5 times before I draw the image again. For level 1, I would just go ahead and click these buttons to draw that image. And I think I've already forgotten it, but that's the whole idea here. Oops, sorry, I messed up on that one. Let's try it again. There's the image, and now it's going to disappear. Now I have to click 5 times. 1, 2, 3, 4, 5. And I think that it was this. Of course, if I remember it after doing all that other activity, let's see. Okay. All right. So we have to do it 7 out of 10 times. You can see up here on the upper right where it says W and L, that's for wins and losses. And if we go back, and I skipped over the instructions because I was explaining it, but I also can point out here the skills that are being developed. So sustained, selective, divided attention, flexible attention, processing speed, visualization, a lot of sensory integration skills, and some of our short-term memory, particularly working memory. So a lot going on there, and these skills are also developed in many of the other exercises, but in different ways and in different combinations, and that's one of the things that really sets BrainWear apart. All right, now I'm going to do another exercise, and this one's called sky scanning, developing some of those same skills, but others as well, particularly auditory working memory. And what's going to happen is that I'm going to get 3 numbers out loud. I'm going to say them as I hear them, and then we're going to have to find them. This is audience participation part. I hope everybody's playing along with me now. Click on them in order we hear them. So here we go. 33, 60, 18. 33, 60, and 18. Now I have to hold those in my mind while I find the numbers and scan for them. Here's 33, so I'm going to click on that. I may have to hide this. 60 right here. And 18. Can't talk to me. Oh, here's 18. Okay. And of course, every exercise is multiple levels that get progressively more challenging. In this exercise, we'll get to do the numbers in the reverse of the order we heard them, or in numerical order, or we'll get letters and numbers together, and we'll have to do the letters in alphabetical. So it really is going to give our working memory skills and our visual scanning and our auditory processing, visualization skills, all a very good workout. Okay. So again, just a little bit of a flavor of it to give you an idea, especially because the program looks quite different from other, stop screen sharing, and we'll go back to our slides. All right, we did that part. That's good. Just a flavor of it, and invite you to explore some more. So the next thing we want to talk about is cognitive assessment. And of course, we're going to address the why first. As we have come to understand more about how brains learn, it's really becoming clear that learning is the process of the brain creating itself. We have to create, activate, and strengthen neural networks in various parts of our brain for learning to take place. And this has been explicitly recognized in something called the Universal Design for Learning, which many of you may be familiar with. And UDL basically describes both the what of learning as well as the how of learning, and then the why of learning, and connecting it directly to some of the networks in our brains that are responsible for each of these and that all have to contribute to the learning process. Universal Design for Learning is also closely connected with the concept of differentiation or individualization or personalization, depending on what you call it. If you find those things, because I don't think there is yet a general consensus on exactly what each of those means or if there's any difference. But the basic idea of personalizing learning is that it has to take into consideration the student's interests. It has to take into a consideration of how they learn, what their learning profile is. It has to take into consideration their readiness. So if you think about the concept of prior knowledge, what they know, or what they have to be able to do to learn what we're trying to teach them. And finally, the ability for the student himself or herself to control some of the learning process. And so when we look at a cognitive assessment, next we want to talk about what it means and how we can use that. So these are examples of learning profiles produced by a cognitive assessment called Mindprint. This is another one of those tools that if you would like, if you're a clinician or a school and would like to explore this more, we are happy to provide and set you up with an account to experience it, or as well to walk you through and talk more about the options for using it in those environments. But for now, I just really want to talk about how it's important. So these are two learning profiles, two different students. Both of them struggle with math. In fact, their struggles look a lot the same. They're slow, they have trouble remembering what they learned before and solving problems. But when we look underneath, what we're going to see is that they're really different learning profiles. So the student on the left has a weakness, or he's not really, or she, I can't remember which it is, not really, really low, but low in the low expected range in working memory. So if you think about working memory and how you're going to have to hold math information in your mind while you're solving the problem and think about how you're going to do that, that's going to mean a different thing than this other student who has a weakness in abstract reasoning. So the student who has a deficit in working memory or a lower ability in working memory, it's going to be important for that student to show their work because they simply are not going to be able to hold it all in mind at the same time. Providing them with visual reminders, the steps that have to be done, and having good automaticity and core skills because they don't have enough mental real estate within working memory to think about it as well as try to solve the problem. So we want those skills to be truly automatic. So a child with abstract reasoning, lower abstract reasoning issues is going to be a completely different kind of situation. This is using critical thinking to solve problems in a visual form, and the problem is sort of like a puzzle or a maze, but the child might still use word-based reasoning. And so what you are going to have here is someone who has some difficulty and isn't very quick at understanding new math concepts or coming up with a hypothesis in science or understanding a complex plot in a novel. So here, talking through the problem, that is using their verbal skills, verbal reasoning skills to identify, talk about, and label the problem with verbal tags is going to be important. Drawing a picture so that they can visually see the connection among parts of the problem, and then making sure to activate prior knowledge so that they can explicitly look at whether this problem is the same as another problem that they've already learned to solve, or what about it is different. So two very different kinds of learning profiles that we're going to help in very different ways. So the Mindprint assessment is an online cognitive battery. It takes about an hour to administer. It was developed by the University of Pennsylvania Brain Behavior Laboratory. It has been normed on over 10,000 children and many adults in an NIH study, and supported by really terrific peer-reviewed research that's been published in a number of different places. Very high correlation with the WISC and the RAT, if you are familiar with those particular cognitive assessments often used by clinicians. But one of the great things here is that this assessment can be administered by a teacher or by a parent. It's appropriate for ages 8 to 21, also requires a PC or a Mac to be able to use it. And I have already showed you the learning profile. I guess I need to do this slide first though, don't I? Okay, so these are the test areas. Each skill, the student will get a score for speed and for accuracy and understand how they compare to national norms. So whether the student, it's a particular strength of theirs or a particular weakness of theirs, or whether it's in the expected range and sort of where it's the top or the bottom or the middle of that expected range for each of these. And that can provide us with a lot of wonderful information to support them in their learning. And in fact, I've already showed you sort of the overall. You can see here these green areas are the strengths, the purple areas are the skills to support, and the blue is everything, all of those skills that are in the expected range. And then the rest of the learning profile gets very specific and very explicit about how to reinforce strengths and how to support skills that need to be supported. So here's an example of a student who has a strength in visual memory. And the student can use that strength if he or she, for example, struggles with learning written information. So with stronger verbal skills, the student will be able to, or less strong verbal skills, the student can actually use that great visual memory to create visual images of things, to create vocabulary with pictures, to do visual note-taking. All that kind of thing is going to be a way for the student really to leverage that great strength that they have to be more effective as learners. This is an example of the part of the learning profile that would explain a specific need. So in this example, this is a student who has weak, flexible thinking, which means they have a hard time changing how they look at things. This is exactly what cognitive flexibility is about. And for this student, it's something that needs some support. So this type of student may struggle if they're confronted with a novel task or when asked to adapt to unanticipated changes. And that leads to a set of resources that are and suggestions that are specifically designed for that to help this type of student. And in fact, the Mindprint toolbox, this is just a screen capture of that, contains hundreds and hundreds of free learning strategies for the classroom, as well as reviews of apps and games and workbooks. And here you can see the personalized toolbox of resources for this student named Sam. The green boxes, these are links to various resources, represent tools to help reinforce the strengths. The purple boxes are those to help with skills that need to be supported, and the blue ones are, the ones that are in the expected range. But it's very specific and it's very personalized to the learning profile of this individual student. Michelle's asked a question about how many times the person has to take the assessment to get reliable results. The tool has been, is very, very reliable. That doesn't mean, of course, that you can't have a bad day or have a child who's resistant to taking it. That you would want to, generally, one administration will be give you really great results and really meaningful results. If you have that kind of situation, then we would have a conversation about how to deal with it, and we might recommend in that case a second administration. Okay, our third one, and remember, if you want information on or an account to play around with and experience for yourself with any of these, we're going to give you that information at the end. So the third tool is a reading program that explicitly develops the cognitive skills most closely involved in reading. But first, the why, of course. Why do some children learn to read without much help at all, while others really struggle, even when they're all getting the same kind of instruction? And a lot of it comes back to cognitive skills, also some other factors. But this is information from a brand new report from Digital Promise. Digital Promise is a quasi-governmental organization, and this report is actually one of the resources in the handout. So if you're interested in looking at that, there's a copy there. So they work with researchers, with educators, with entrepreneurs to try to create a roadmap of product development to address the best understanding of the research in the areas of various areas of education. And what the report does is summarize the research on various factors that enable an individual to learn to read. So when most of us think of reading, we think of things like decoding, we think of phonemic awareness, we think of comprehension, we think of fluency, building fluency. But as this report really emphasizes, cognitive skills, things like attention and long-term memory and short-term memory and visual processing and working memory are all really essential aspects of the reading process. There are some specific reading skills, there's some social and emotional skills, there's student background. And if that list of cognitive skills looks a lot to you like those skills that were trained in BrainWare, you would be absolutely right. And it's really exciting and gratifying to see this kind of summary of the research where the evidence has really built up to a point that there is a lot of consensus on this. So Skate Kids and Ramps to Reading are the tool that we'll be talking about. Skate Kids is for older students, more or less ages 7 to 12. Ramps to Reading can be used as young as 4. Ramps to Reading does not assume any independent reading ability. Everything is auditory. In Skate Kids, it assumes a very basic reading level to start with and takes it up through grade 6 reading level. So what both of them do is integrate the cognitive skills reading along with the literacy skills from the traditional have-to-haves that we know about reading. It was based on the work of a researcher, a cognitive psychologist named Jack Naglieri. I don't know if you guys are familiar with him, but he's well-known, renowned, is the author, a co-author of a number of cognitive assessments as well. And it was his PASS theory of intelligence that is the foundation of this. PASS refers to planning, attention, simultaneous, and sequential processing. It can be used along with any curriculum or any direct instructional setting. It is a supplemental reading program. It's delivered also in an engaging digital game-based format. And so we're going to take a look at that in just a minute. But what we want to do is take just a quick look at some of the research. And again, several research studies have been done on the effectiveness of Skate Kids and Ramps that show a strong correlation with improvements in reading scores. And in this study, Skate Kids was used by about half of the students in a medium-sized urban district in the Southwest US. The students using Skate Kids had a significant increase. You can see that nice little hockey stick rise in their reading level, while the students not using Skate Kids had a slight decline. That decline was not significant, but the difference between the two groups is very significant. Interestingly, the district had a substantial Title I free and reduced lunch population. And as you can see, the students who use Skate Kids really started to narrow the gap in their performance level really considerably over the space of just a few months. So my next task is to give you a little bit, just a little flavor of Skate Kids. And I'm going to again share my screen with you. And, okay. No, I gotta do this up here. That will work. This is a completely online program and can be used on a PC, a Mac, or a Chromebook, not a tablet though, at this stage. So I'm gonna go ahead and log into Skate Kids. And you're not gonna hear the fun music and that kind of stuff, but I will again, tell you if there's anything you need to listen to. So I'm going to log in. And the first thing that comes up is a video that the kids find entertaining. Of course, all of the theme is about Skate Kids and skateboards and snowboards and surfboards and all kinds of fun stuff. So very, very engaging. So these are all of the different games within Skate Kids. There are three basic kinds of games. There are ones that are primarily cognitive. There are ones that are phonics based. And then there are some that are comprehension based. So I'm going to give you, we're going to again just do a couple of examples and remind you that if you'd like to get an account to try out for yourself, you are welcome to do that. So this is an exercise, a cognitive exercise called Board Tech. And I'm just going to go ahead and start at the very first level. So we're going to have a skateboard, and it's going to have some shapes on it. And then we're going to have to, they're going to disappear, and we're going to have to recreate the design and get it to be the same as the one that disappeared. And then we'll see how we did. So here's the first design. There are 3 circles on the board. A yellow, a purple, and a blue. And I'm saying that out loud, so hopefully I'll remember them when they disappear. And you can see that we, while the shapes are all the same, we're just going to have to put 3 circles up on the board. And there are hot spots, so if you don't get it exactly in the right place, it will pop into place. Now, of course, the circles all start out yellow. And we know that they weren't those colors in the original design. So now what we're going to do is we're actually going to have to change the colors. We go up here to our paintbrush, and I think it was purple. The second one was purple, and I think the third one was blue. And if you guys think I'm wrong, then you'll be right and I won't be, I guess. But anyway, so we check my answer. Oh, I did it. Okay, great. So now we're going to get another design. This one happens to be, I call these flags. I don't know if that's really what the shape is called, but that's how I think of them. And I'm not going to try to remember this because I just want to give you an idea of what's going to happen when we get up in different levels of the program and it gets more challenging. Because we have several tools here that we can use besides the colors. The first one was just about changing the colors, and that second one was also just about changing the colors. But when we get up in levels, we'll have these other tools to use. This one is a rotation tool. So we can have a rotation. This one makes a shape bigger. And the last tool flips a shape. So creates the mirror of it, which as we know is very different from rotating it. And so you can get all the combinations of all these color changes and orientation changes and size changes. And as we get up in the levels, it will become quite a bit more challenging, a lot more information to hold on to remember visually and create ways to chunk the information and develop strategies to remember it. So I'm going to go back now. And as I quit, you're going to see me racking up a whole bunch of credits here. And those are things, credits that I'm going to be able to spend later in the virtual mall, which I may show you. If we have time, I'll do that really quickly. Okay, quit. I can't really do the phonics because you won't hear it, but there are several. Snowboard Blast and Space Bumpers are phonics. I am going to show you, however, one of the comprehension exercises. And this is where this program really distinguishes itself. Most comprehension programs involve reading a text and then answering questions or filling in blanks with words. But what we're doing here is we're really using the cognitive skills that we need to have well developed directly in the reading process, like working memory and visualization, our ability to see, remember, hold on to the information in a much more authentic, real way. So this is going to start off, of course, with the very, very basic text. And then we're going to have to recreate the scene. And this is Gallup Park. These are all of the skate kids. These are their various things they might be doing, from using a computer to reading a book, coloring skateboards at different times of the day. So we're going to just try this one out. See, I said it started off very basic. Tan is on one bench and Kaz is on one bench. So I'm going to put Tan on a bench and I'm going to put Kaz on a bench. And then you're not going to be able to hear this, but I'm going to tell you what it says. Wowzers is what it said. And now we're getting a little bit, still a very basic one. And this will get progressively more challenging. As I said, at the most difficult level, we're going to be reading text at a 6th grade reading level that will require us to sort through the relevant information and screen out the irrelevant information. It's going to require us to make some inferences. So it's definitely reading at a higher grade level by the time we get done. Oops, I just closed the whole thing. So I'm not going to be able to show you how you get to go to the virtual mall. You will have to experience that for yourself. So now I'm going to go back. I have to go back, and I'm going to stop screen sharing. Yes, I do. And this is, nope, that's that. That's going to get my slides back. Where are my slides? All right, they're coming up. All right, so that was a little introduction to skate kids. Then the final approach that we want to talk about a little bit today in terms of brain neuroscience of the classroom is literally doing that. You know, it may seem trivial to talk about the brain being the organ that learns, and the teachers should therefore understand something about it. But there have been a lot of barriers. And most teachers don't hear the word brain still in their, maybe it's changing a little bit finally, in their teacher training programs. You know, and education is there, the barriers are, you know, education's been around for well over 2,000 years, but real understanding of the science is actually fairly recent. In fact, 90% of the neuroscientists who have ever lived are alive today. The second is the challenge of translating the science to strategies. And the media, the general public, and teachers along with them have made some missteps in the process. There are persistent neuromyths, things that people believe that are really not correct. And so it's not just about knowing the right information, it's about knowing the things that we've all heard that maybe not be correct. So here is a little exercise for all of us. And we're going to read these statements. I'm going to give you a chance to read them because I'm not sure what will happen when the poll comes up, and I don't want to cover them. But basically, I'm going to open the poll in just a minute, and you're going to read these statements. There are 5 statements, and you're going to decide how many of these you think are true. So I'm going to give everybody just another few seconds here to make sure they have a chance to read through the statements and figure out what you think. All right, so here comes the poll. And I'm going to open that up. Okay, so everybody should be able to see the poll. And your job is to figure out how many you think are on the slide are true. Okay, so we have about, we're getting a few responses. I'm going to give everybody a little bit more time to decide how many you think are true. Okay, seems to be pretty stable at this point. So I'm going to close the poll. And interestingly, I'll make sure I get that. 3, 0, 1, 2. Okay. So if you are one of the people who said that none of those statements are true, you were right. These are all neuromyths. So we had 2 people out of the about almost 20% of the group that got that right. And if you think about it, and we have a range of backgrounds on this webinar today, just looking at the people who registered, everything from parents to teachers to consultants to clinicians, so quite a big variety. And in fact, but many of you thought that at least 3 or 4 of these statements were true. So just quickly, the using 10% of our brain is a very, very popular and very persistent neural myth. Most, at least half, I don't know exactly what the statistic is, but it's a large percentage of teachers as well as parents and others still believe this to be the case. And it's been encouraged by movies, and all kinds of different things. But the fact of the matter is, if we didn't need all of our brain, we wouldn't have all of our brain. And our brains are always doing something, all the parts of our brains. We don't know how much of the potential cognitive capacity we use. We don't even know what that is, or how much it can be developed. So in that sense, we have lots of opportunities to improve that. But it's not really about physical space in the brain. And we actually use 100% of our brains. Our brains are active when we sleep. Our brains are active when we think we're not thinking about anything. Our brains just doing a lot of things all the time. The second is also very persistent and a very strong neural myth, that people learn better when they get information in a single preferred learning style. And we talk about visual learners, auditory learners, and kinesthetic learners. But the fact of the matter is this has been largely debunked at this point. And what we know about learning is that we all learn using all of these various modes, that we all will learn better and deeply and more deeply if we are exposed to information in a variety of different ways. So if you think about the fact of, let's say, if you're learning something and you're listening to the teacher and you're getting auditory information, well, that means that information is being, the neurons, the network of neurons that are being activated when you're learning that are those auditory processes and those auditory traces. And so when we go to reactivate that information, that's the way that we have to activate it, unless we've processed it or unless we've been exposed to it in another way. So when we have information that we see, that we hear, that we engage with in some kind of motor way, we're going to have a lot more ways to access that information to help retrieve it when we need to. So the stronger understanding from neuroscience these days is that you want to incorporate a variety of different modes of learning in our instruction. The third is left brain and right brain. Again, this is very, very persistent. I can pick any number of people that will talk about left brain and right brain. We do have 2 hemispheres. They do control different sides of our bodies. They do specialize to some degree, but we can't do much of anything without them working together. Everything we do has them working together to create the full picture. And so trying to cater to a particular side of the brain really has no value. What we want to do is have all parts of the brain actively working and working together, because that is actually going to develop into both intelligence and our ability to learn, and much stronger and deeper learning. About 6 to 8 glasses of water a day. We certainly want to have enough water, but if I had a classroom of 3rd graders who was drinking 8 glasses of water a day, I think they'd spend more time in the bathroom than in the classroom. But and it doesn't cause the brain to shrink. Our brains are not going to lose mass that easily. Much more important actually to get physical exercise. If you got the kids up and moving once an hour, that's going to be far better for their brains than trying to cram a lot of water into them. And the last thing, learning problems associated with developmental differences cannot be remediated. I think as we saw earlier, there is now strong consensus that, in fact, we can remediate many of these underlying cognitive processes for students who have not developed them initially for a variety of reasons. And that in addition to our standard approaches of accommodations and curricular adjustments, and the strategies that we teach them, we can also incorporate remediation as a way to really benefit and help our students learn much more efficiently and joyfully, actually. All right, so we've got, one of the things, in addition to those explanations, we do have an online quiz, and maybe Karen, if you wouldn't mind pasting that link into the chat window so that people can actually, you'll have a copy, you'll have the this URL in the slides, but I thought that if Karen could paste it, well, no, I don't still have it. So I was going to ask Karen to paste it. She may be helping somebody with another issue, but oh, there it is. She found it. So this is, you can actually click directly on this, or you can copy and paste it from the chat window. This is an online NeuroMyths quiz that has connection to the explanations. And this is a fun way with your teachers, or even with your students, for that matter, another very practical way to bring neuroscience to the classroom is to help their students understand a little bit more about their brains as well. Okay, and then the final, all of this is to say that there are ways to help teachers understand and apply neuroscience better in the classroom. We do this in a variety of ways. We call it brains on, because it's not just a hands on, we want our brains on. And what we've really done in developing these various programs is put a lot of emphasis on modeling the brain compatible practices that we discuss. So I have a colleague, actually many of you probably know of her because she's quite well known in this field. It's Dr. Patricia Wolf, who wrote a book called Brain Matters, which I highly recommend. And I'm going to type that in. If you haven't read this and are interested in this field, Dr. Patricia Wolf. That's one I highly, highly recommend. Anyway, she was describing a typical professional development that goes on in many schools and districts. And she said most of it's delivered by the seagull method. She said, you fly in, you drop your load, and you leave. And of course, we don't think that the seagull method produces much in terms of long-term retention and application in the classroom. And so we have worked very hard to really model the brain compatible practices that we talk about. And there are a lot of ways to do this. People do different ways, but just to give you a couple of examples, we do full or half-day workshops on how the brain learns. This is general grounding for teachers in what happens when the brain learns, different types of memory exercises and how we apply that. It's very, very hands-on, and goes all the way from sort of the, like we call our online course, from synapses to strategies. We've also recently developed a half-day workshop on growth mindset. There's a tremendous amount of interest, and we're finding that a lot of schools are actually focusing on growth mindset this year. That was our last webinar, and has been a lot of interest in this area. So those are sort of the traditional day or part-day workshops. We also have a program that goes all the way through that, from the basic brain science to how you incorporate this in a brain compatible lesson plan, and incorporating instructional strategies. And this takes place over a period of about 3 months with a cohort of teachers, and includes some embedded coaching in that process. And then we also have a self-paced online course called From Synapses to Strategies, and that's about 10 hours to complete, but completely on your own pace. Okay, so that's the fourth one. So this is what we've touched on today. Cognitive training, BrainWear Safari, cognitive assessment, Mindprint, cognitively based reading, skate kids and ramps to reading, and professional development. Each of these is worthy of a fuller presentation, but I hope what we've been able to do is just give you a sense of the degree to which it is possible today to leverage neuroscience to improve teaching and learning. And again, if you're interested in trial accounts, I'm going to jump quickly to my contact information at the end. And then we're going to go back and do some questions, but I want you to have access to this. So if you are interested in experiencing, trying out any of these programs for yourself, here's how to reach me. You can call me, you can email me. I haven't had much success with carrier pigeons as a communications mode, but any of these others is certainly fair game. And now I'm going to go back. Oh my gosh, I do have a typo on that one, Karen. You know, no one saw it in the last webinar because I had it's the same final slide. So thank you for correcting that. Sometimes it takes a few runs to make sure that all those things we've looked at many times are accurate. All right, so happy to answer any questions, hear any thoughts that anybody has. Still have a few minutes if there are any questions or any thoughts that anybody would like to share. Or if they'd want to tell us about how they saw the eclipse yesterday, that would be good too. Michelle was talking about the graphic. I think that was the Universal Design for Learning. So if you just Google, do a search for Universal Design for Learning, that should be one of the things. It's on the website of an organization called CAST, CAST.org. Also asked about the source of the reading and the text in Skate Kids. I believe that those were all developed by the team, the educators and the neuroscientists that worked on that program. So I don't believe that there is a different outside source for that, but I can double check that. Monica is saying, how can we set up a trial account? All you need to do is email me and say that you would like a trial account. Since we've talked about a number of different programs today, if you would let me know which it is that you are interested in trying, or it can be more than one, of course, but BrainWear Safari, which is the cognitive training program, Mindprint, which is the cognitive assessment, Skate Kids and Ramps to Reading, which is the cognitively based reading program. And then if you're a school or a clinician and would like to check out our online From Synapses to Strategies course, we can also set you up with an account in that. So 4 opportunities to learn some more. Okay, we will, thank you, Becky. We will take care of that. Hi, Lou. I didn't know Whitaker was on today. Lou Whitaker is one of my partners in crime in understanding and teaching about the brain. Deborah is asking about cognitive skills and mapping to state standards. So it's possible in a very general way. For example, if you took the Digital Promise Report, you can map those cognitive skills to reading. But they don't really map to state standards, because state standards are about the what. They're about what we want kids to know. Cognitive skills are about the how. And nobody tells you the how. And sometimes we struggle with trying to figure out how to do that. So the cognitive skills are implicit in state standards. They're implicit in particularly the Common Core, whatever version of the Common Core you may be using, where we're trying to reach higher orders of thinking and things like that. And in fact, you need these underlying cognitive skills and executive functions and higher order executive functions in order to be able to do those kinds of things. But they're certainly not explicit, and they're not unique to a particular standard or to reading or to math. It turns out we only have one brain, and we use it for reading, and we use it for math, and we use it for science, we use it for everything we do. And so working memory or attention or visual processing, we use those skills in pretty much everything we do. All right, I'm just, and Judy Belk, hi Judy. Thank you so much. It's, all right. Okay, well, we are exactly at noon, and I think we've addressed the questions. If there's something you wanted to ask and didn't get a chance to, by all means, email me. This is, we love to talk about this and share with you examples of how people are implementing this in real life. Oh, Annette is talking about academic standards. ESSA, requires some non-academic measures, and cognition can certainly address part of that. And it's certainly inherent in everything. Okay, well, we hope you'll join us for another webinar someday. Most of what we do are topics that are not as directly about product-specific kinds of things like we did today. They're more about sort of general neuroscience information and how it is used in teaching and learning. So I want to thank everybody very much for spending some time with us today. We really appreciate your being here, and we look forward to continuing the conversation as we go along. Don't hesitate to be in touch if there's anything we can help with. So thanks again, and have a great day.